Now that we know that polar covalent bonds exist, it is time to understand why they exist. A polar covalent bond will form between two atoms if they have sufficiently different electronegativity values. Electronegativity is a measure of how well an atom can attract electron density towards itself. The more strongly it can attract electrons, the greater its electronegativity. Electronegativity will depend on atomic radius, since a smaller atom with a greater effective nuclear charge will attract electrons better. So the electronegativity trend will be the same as the ionization energy trend. It will increase up and right on the periodic table. Fluorine will have the greatest electronegativity, and francium will have the lowest. We will exclude the noble gases from this trend, as they are not likely to share electrons, making electronegativity meaningless for those elements. We must make the distinction between electronegativity and electron affinity, because the latter involves an actual ionization and an associated energy change that is measurable. The former just describes a calculation of how well an atom attracts the electrons in a covalent bond, so it is not measurable, and it is listed on an arbitrary relative scale from 0 to 4. The electronegativities of the two atoms in the bond will tell us what kind of bond will form between them. A polar covalent bond will occur if the two atoms participating in the bond have an electronegativity difference of somewhere between 0.4 and 1.8, as this is a difference that will allow for electrons to be shared, but unevenly between the atoms. If the electronegativity difference is larger than 1.8, the electrons will no longer be shared. One atom will steal electrons from the other, and an ionic bond will form. If the difference is less than 0.4, we say that it is essentially nonpolar, or pure covalent, where the electrons are shared roughly evenly between the atoms. Another way of stating this is saying that as the electronegativity difference increases, the ionic character of the bond increases, from pure covalent to polar covalent to ionic, or from electrons shared completely evenly to not being shared at all. To find out what kind of bonds will form, just consult the table of electronegativity values. So we can see now that it is electronegativity that is the parameter that determines the type of bond that will form between two atoms, and that it explains how and why the variety of bonds that exist will form.